All right, we are live. Well, welcome back. So today we are continuing the writing of a city building game from scratch in Golang. So last time we implemented a very basic canvas, as we can see on the screen overlaid. We have been able to create houses, as indicated by H. We have been able to create a road, the dash, and the houses are spinning up workers that are wandering around. Right now there is not really much happening, but it is a start. So today, the goal is going to implement at least one other building, probably the well, and if we have time, maybe a bazaar, and a concept of resources. So that way we can have like employment and water and maybe even food. But first thing first, it would be nice to save our progress because right now we don't have another Git at all. So like let's initialize Git. We can go to GitHub /Quick, which would be me. I thought I was signed in, apparently not. Maybe it's because I am in incognito mode. Let's just create a new one. github.com. That is going to create a new repository. And how did we call it? Come on. Epocolis. City building game in Golang from scratch. Good. Well, we can, why not add a small git ignore. We can make it an MIT license. We can add a readme because, I mean, why not? Public, yes. All right, now that we have this, we're actually just going to clone that. So let's clone this and git clone. Okay, whatever. mv epocolis star.md epocolis. Now we have all this, so we're going to add .git ignore /tmp. Git st. All right. Wait, no. Did I mess up something? Okay, whatever. Not a big deal. Git add of everything. Git c initial draft. What do we have? All these roads, worker. And actually, like on my work email, this is not really expected, but not a big deal. Not a big deal. Push dash origin main. All right. Set git trick. I'm still. Actually, I really don't like having this. Let's just get rid of this. Oh no, it's fine. It is fine, it is fine, it is fine. I can take it out of that later. It's not really a big deal. And git push dash f, whatever. All right, so now we are ready to get started with the next step. What is going to be the next step? Do we have something live? Main.go. Let me go back to my main screen. All right. So this is what we have, and now we want probably want to have the wanderers to be able like to go north and south as well. Or not. Yes. Okay. First thing first, let's do the up and down. So for that, we need to actually implement better roads. And before implementing better roads, we need to place the roads. Because right now we are still just rendering them. We do this to place them. So like, let's add a few more. So that is going to be 3, 4, let's put that in 5. So that should give us another row of roads. Now if we do something a bit different, some 4. And if we start maybe not at 6 but at 4, where we can do 2 plus I. Let's see. Okay, that is what I expected. I put it like one before, just to confirm. But like now I can put it at 5, and that is going to be there. I'm going to do the same thing on the other end. We say it's 6 plus 16, so 24. Let's put it at 25 just to make sure it works. All right, so it is 24. And 23. 22. Yes, I mean 16 plus 6 is not 24, it is 22. My bad, but it is good. Next, we will want to render that a bit better. Good thing that we already have like all the characters from the building box. And that is the character we want. I mean, those 2 characters are the characters we want. So let's go to road and say that by the default one is still going to be that character from the building box, and if it is a vertical one, we're going to return this guy. Now, how do we know which is which? And last time we implemented like a function to get the neighbors, and we also implemented the function to implement to a filter based on the type. So we can do this, and we can say nays. But actually, like, no, we don't really care too much about that. Let's do something a bit better. We're going to do like a var left, right, right, up, down, right, left. Everything's going to be a bool, everything has to be false. And here we're going to do, what are we going to do? We're going to do like up equal at up. I really don't like this. I really don't like this. Let's go back to our base. And here we're going to add like maybe a bit more helpers. So like right now like we have the get and sets for like the current one. And now we are going to add just a few more gets. Get nay. Dir. Worker direction, which we're going to rename into just direction. And because we rename that into direction, we're going to rename all of those too. Direction north, direction south, east, and west. Okay, that still compiles, it is good, so we get the direction, and then we can do a tiny switch here. And we switch default, default, panic, and then direction, and that is going to be our direction. All right, and so we can do a case direction north, south, east, and west. So if we go west, west is going to be x minus 1. And of course, if we basically if b dot x minus 1 is inferior to 0, we return nil. If we're east, it's going to be return b.grid of b.y, b.x plus 1, and if b.x plus 1 is greater or equal at len of grid of b.y, just 0, return nil. Maybe we could panic, I'm not really sure yet, but let's start with this. Source is going to be 1 lower, and because we start at the top, it's going to be plus 1 to go south. And if the b.y is greater or equal than the len of the grid, at this point we return nil, otherwise we return g.grid of g.y plus 1 of g.x. And finally, if b.y minus 1 is lower than 0, we return nil, otherwise we return g.grid of g.y minus 1 of g.x. So that is going to give us our neighbor. There is something wrong here because I forgot to switch on the direction. And this is not a g.grid, it's a b.grid. B.grid. Alright. There's still something missing. Where did I do the g? Yep, it's not g.y, it's a b.y. Something here. Almost there, like where did I do a g? Okay, b and b. Oop. Let's see. And it compiles, that is great. The road are not looking too great at the moment, but it's not a big deal. Let's get that fixed real quick. Now we can do a switch. So now we can do a road dot get nay of direction east. That is great. And that's going to get us that case. And we can also do a filter on that. And the filter is going to be a grid case of this guy. And we can filter it on star road. So that is going to be east. But let's do like a north, south, east and west. Direction north, direction south, direction west. Now that we have all this, we can eventually do our switch, a big fat switch. That is going to do what? It's not north, it's north. Alright. Now that we have our north, we can say that if we have a neighbor on the left or the right, but no neighbor on the top or the bottom, then it's going to be a horizontal line. So we can say if east or west, and no north, and no south, at which points we return this guy. Same thing for the vertical one. We can say if we have north or south, but no east and no west, then we return this guy. Default, return a question mark. Let's see what's going to happen. That would actually make a lot of sense, because the filter is always going to be that thing. Yes, I was hoping that would work, but actually it does not. So let's make it a bit simpler. It is going to be the neighbor itself. Yes, I'm not really sure why I did this, but it's fine. Star road. Something like this, yes. And because it's a block, we can make it a block. It will be just slightly nicer. Come on, come on. All right, cool. So now we have our roads left and right going good, and now we are missing the corners. So what is a corner? A corner is going to be the case where we do have, let's start by the first one. So we don't have west, we don't have north, we do have east, and we do have south. In which case, no, let's go this direction, let's go back to the main and to our box, and the first corner is going to be this guy. Let's see. Not too shabby. Next one. We are going to have, we have a west. We don't have a north. I mean, not so sure why I did it that order though. Let's fix that. So let's say no north, south. Southeast and no west. That would be better, so that way we can use the same order everywhere. Okay, so in this case we're going to return the other one, which was this guy here. And we will have the four corner. Not very sure exactly yet what is going to be the other one, but we will do that very soon. We just know it's going to be four corner. All right. So the first one is good. Now the second one is going to be if we don't have a north, we do have a south, we don't have east, and we have west. Awesome. Next one on the bottom left is going to be we do have a north, we don't have a south, we do have an east, and we don't have a west. And this one is going to be very similar. We do have a north, we don't have a south, we don't have east, and we have west. Awesome. So now we have networks that are looking good. We are missing like the crossing when there is like something in between, but we will deal with that a bit later. Oops. Next, we want the wanderer to be able to go to follow the road. So let's do that. We go to our worker, and the worker, instead of just stopping here, we're going to add the two more direction, probably at the beginning. Yep. Case direction north, case direction south. And what do we do with those cases? First thing, like we need to basically to end up in that state because we default going east. Now we want to be able to go north or east. So basically, instead of going back in the direction, we need to have some logic, and we need to find all the roads that are available to us that are not ourselves. That is actually a bit complicated. How are we going to do that? Let's see. We are going to do... How can we do that? We have that worker dot neighbors, which are my neighbors. By the way, here we can actually replace it with our function, because here we are going that get direction east. Something here we can do that gets direction west. All right, but here we have all our neighbors that are filtered by road. And we want to find which one we're going to use. That's actually not too bad. That's actually not too bad because we know that the current one is the one where we don't want to be. Do we have a reference on our road? We do. It's w.get. W.get is actually where we are right now. So let's actually do that before we make the change. So, cure road is the value that gets dot star road. That is our current road. We know that. We can even do that right here. Road. All right. And we get our neighbors. And we can say basically like next road star road. Basically, which one is going to be the next is going to be one of those LM range on those. And we can say that if LM is not we probably need to have some kind of candidates. Next, just candidates of star rod. If the element is not the Q rod, then we aggregate it to the candidate equal at append of candidates of LM. So that is our candidates. If the length of candidates equal at 0, if we don't have any candidates, like we had at the beginning, if we're already at the end of the road, we say that the next road is going to be the current, actually, if we don't have candidates, we do what we were doing before, meaning we just do the direction equal at direction west. Else, if a length of candidates equal at 1, we go in that direction, except that we don't know that direction. That is a bit annoying. That is a bit annoying, so it'd be in the neighbor. It would be nice if we get that information as part of NEI. Let's add it. Let's see like how much are we using this. Let's first, okay. We can add that information because this is actually quite important. And it does not compile anymore. Why doesn't it compile anymore? Too many arguments, because it's get nay. Something here, it is get nay. All right, so this is working. Now when we get our neighbor, we would like, but then the filter is not going to work. So maybe we need a different approach. Let's take a step back. And we say that our neighbors is going to be, and our candidates, once we're going east, the candidates are going to be by the north, south, and west, and east, because this is where we're going. Yes. We can get rid of that check because we do that check in the getNay. All right. Basically, we can go much more simple. Or east. Basically, when we're going east, we're always going to try to go east first. But then here I'm thinking if we have more than one. But for now, let's start with without if we have more than ones. North. And so if that is the case, we do basically if we have someone on the east, we don't change the direction. But if we do, we do. Okay. So now we do W the direction, equal direction north. If we have someone in the south, south is going to be y plus plus, I think. Yes, because it's a bit less, and it means that we're going south. And if it's not, basically if it's none of them, it is direction west, so we can do d dot x minus minus direction west. That will be what we do, and of course we also need to do the previous one. Well, it's going to be on the next one. Anyway. So you probably don't need to do all of this, do we? Yes, because here it's not RN, here it is RE. And here is RS. All right. Really not a fan of that, because yeah, really not a fan. But no, that is not going to be suitable. That is not suitable at all. So how can we fix that? The idea would be to do that in a generic way that we can basically apply to everyone. All right, let's add a tiny helper. W.worker, let's do it a move. Direction. I believe that may help us clean up a little bit, because we can do a small switch on the direction. Default panic FNT and non-direction. There. We can do the switch, the case direction north, case direction south, case direction east, case direction west. And that is going to be just the move itself, and it's going to assume that it can move beforehand. So in order to do that, the move is basically just this. So when we go east, I'm going to keep track of that here. Let's go see, once we go east, move, okay. Let's start with move east, because this is where we started. It is going to be W dot X plus plus. And we can also set the direction, direction to there, because we move. And so when we move, we can say that the W dot get .starRod.worker equal nil. So that is actually the move. And to do east is plus plus. To go west it's minus minus. To go south is y plus plus. And to go north is y minus. But for that we need, of course, to make sure that we can move. But should be fine. Like, let's make it a note. The caller must check that the move is valid before calling. Should be fair enough. Next. Once we have this, we can use it a bit easier, I would believe. So in order to check, can we move and where can we move? Well, we can also have like a small w.worker look up direction of a neighbor, which is going to be a road, and it's going to return a direction. So basically, this is going to take a road and return the direction from where that road is. So we can do like a small switch. Case w.get name of der ist. Actually, we can do not even a switch. We can even just do a loop for their range of direction, of all our direction north, direction south, direction east, direction west. We get the neighbor of the direction, and we say if the neighbor is, first we need to make sure that if OK is the w.get name of the direction. If OK and then r equal at nay, return there, and if not, return 0, because 0 would be a bad, like an invalid direction. Get nay. Of course, we need to cast that to starRod up. So that is, excuse me, that is pretty good. And we want also to have a small filter to filter out self. Let's do that. We can do that here, or we can put that next to the other filter in the base. So we can do like a func. First, we can rename this guy into a filter type. Func, and filter type is maybe like a, I mean, it is a filter type. Filter lm. That can be t any in t and return t. Nope. Filter out single lm. Let's be a bit explicit, because here the goal is to filter out that element. So we can do var out st, return out, and we can say for lm a range of in. If we have in, we do like out equal at append of out of lm, but only if lm is not in. That should be quite straightforward, and of course that is not the case. In 30 LMT. It's of course LM let's call it F because it's what we filter. And LM does not like it. Why can it compare this? Okay, let's make sure that it is a pointer so it can be compared. And here as well. Okay. Cool, so now we have our filter, so now we can go back to the worker. We should be able to get rid of all this, so now we can just do like get nays to get, excuse me, just dot nays, so that gives us all the neighbors, and from the neighbors we filter them by road, so this is going to give us all the roads that are next to it, and we're going to do, it's not filter now, it's going to filter type, and we filter out single elements, because here it's like the opposite. We filter out instead of filtering in. This is what we filter. We want to remove self. So basically do it get or just current, because we don't want to get the current rod. And that give it the rods. Nay rods. And that is going to be used pretty much by everyone. That we don't do anymore. We have our current rod, we have our neighbor rods. We can get rid of all this. Let's get rid of all this, get rid of all this. If we're going east, the first thing we're going to do, we're going to look at those neighbor rods. If we have one, it means that we can we still need to get at least one. Because once we go east, we always favor going east. Yes. And if that is the case, and if we do have one, then we do a w.move direction east. So that is always the case. Now, if we are not going east, we're looking at the nay roads. If we don't have any roads, this is where we go back. If we do, then we pick a random one. Next road, rand element of nay road. We can do a w the lookup direction. Equal 0. Next road, and we can of course do a deck.move into that lookup direction. So we can even just make it here. And would that be actually like generic enough that we could do it for everyone? Yes. Yes, because neighbor road would never be 0. We want to filter out ourselves, but this is not really true because we never filter ourselves. A bit more complicated than I expected. Let me think. Yeah, that thing will actually never be the case, because get will never return self. I mean, the neighbors will never return self. The one we want to the one we want to filter out is not the current road. It is the road from where we came from. prev road. Come equal at get me direction west star road. Alright, that is better. Except that horse does not exist anymore. We don't really care anymore about this. No, we cannot compile. Why cannot we compile? Let's see. Current is declared and not used. We don't really use a current road anymore. Yeah, we don't, because we move that into the move itself. Okay. So now we don't move anymore at all. That is a bit concerning. That is a bit concerning. Nope. That makes sense. I suspect there's something wrong with the move itself, and yep, because we remove ourselves from here, but we never add ourselves back. So now it's going to be w.set. Actually, no, it's still going to be .get because we moved. It's still a star road .worker grad w. All right. Would you look at that? We go south. Awesome, 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 awesome. Start to be a bit long though, like I was hoping to be much faster than this. Let's go and let's implement going south, because that's the next one. This time the previous road is going to be north. The neighbor roads, that does not change. The next one is going to be south. We do move south. If we don't have other, we go to the previous road. But we can even do that b.move in the direction north. B.move there west. That would actually make more sense. Let's get rid of all this. Voila. It's good. Now we can take that whole thing and say we're going to go west. This time the previous road is east. That line does not change. We go west, and here we go east. And one more time. This time the previous one is south. South, here we're going to go direction north, south, and neighbor. And I believe this time we should go around and around and around. And we do. However, I still don't like that whole thing. It's definitely better than before, but definitely not good enough. We should be able to make that a way more generic, way more simple. Let's see. When we don't have anything, we go to the previous road. Let's go to our main.go. Let's remove some of those roads. So it does work. At least that's a good news, but let's make it work better. Instead of doing that exception, if length equal at 0, what we could be doing is just say nay roads, what had happened of nay road of the previous. And that way, like, every single one is going to be the same thing. Now the only thing that differs are going to be this one here, and this one there. However, this one here as well could be generic. We could do if okay, neighborhoods. In this case, we override them. Grid case of R. Oh, actually, yep, it was road. That still work. Now we only have this guy here. How to determine the previous road, and that we could make that part of the move. The part of the move. Let's see. In worker we have a direction. We have a base. Probably like the worker probably should have a reference on like which house it is coming from. And which road is it? Cure road. And also like what was the previous road. Alright. So now that we have this, once we do a new worker is always coming from a house, at least for that current version. So we can say like a house, and the current road and previous road. So the previous road is going to be nil each time because this will be a brand new one, and the current road is also nil because once we create it, it does not have one. Actually, does it? It does. So like road star road, road.road, and road. All right, where do we call this? So I just need to update this. So here it's going to be the R, and it's going to be R and H. Which means we can now go back to our worker and do the move, and in the move, we're going to say that W dot previous road equal at W dot get dot star road. And then once we are here, so you can say that W dot current road, W dot get dot star road. Current road dot worker W. And something here we can say just W dot prev road. So that at least give us a sense of what's going on. And so let's go back to our east, we can say if W dot prev road, so that is our prev road. We filter out the previous road. we get the neighbor. We go east, we take it. If not, we do this. And so that way we can take all of this. Nope. Get rid of all that. In our lookup, we have this guy, which we can make a global. All directions. Var all directions. Intervango check no globals expected global expected global. We is not mutable. It's not mutable anyway. All right. I made a typo. All direction. Okay. That's interesting. But yes, because now we want to do like a 4 deer in range all direction. To do that thing here. And we can say that get that's the direction of this guy. If deer equal f dot direction. Move. And even better, we can say if it is not, continue. Awesome. Let's add back the roads, and hopefully it's still going to go around. How awesome is that? And now if we add any roads that like diverge, we don't really have the let's add one in new road. See that new base. Oop. The new road is going to be let's say like 24 for where's that going to place us? Right here. That is fine. And so 24, 6. Actually, no, like let's do 24, 2. And let's make it 23. And that may be like 24 and 25. And allegedly, sometime it should go. Oh no, because yes, we didn't implement the random. Let's actually do that real quick. Golang random int range. Always forget how to do that. There's many ways to make it happen. That seemed like the most simple. Let's do that in our base. This is where we put some things. All right, min-max, okay. That seems straightforward enough. And like we can actually implement it. So in our random, I'm going to say that if len is 0, that is perfect. And that is going to be a range of min 0, and the max is going to be the len of in minus 1. Uh-oh. Why does it complain? And then I'm going to int n. Why is that a panic? Right? Max may mean... oh, it's max... Wait, no. It's min and max. And so you apply here, and the len... Oh. If len of in equal to 1, return in of 0. Let's make it first a bit faster, but then remove also like that second one. And in our worker, let's make a tick slightly faster with 1. And of course, that is not the one I wanted to remove. I wanted to remove the other one. I want to see it go one way or another. And always go to the same one. Great. Okay, so how do we fix that? First, we probably want to include the crossing. Well, like we can do that later for the rendering. My first concern right now is really like why does it never go south? London roads. That is not really too helpful. Let's see. It's always going to be 1, 1, 1, 1, 1, 1, 1, but why? Why would that be the case? Well, I have no idea, so time for more debugging. Let's go to our main. Going to place our worker, like let's just put like in one house for now. And let's place it in right before, I believe it's going to be in 20, maybe? Let's see. Yes. Let's shorten the road. The road is going to start at 19. Nope. At 10. 16. Oh yes, basically like basically 24. All right, so that is slightly better, and now we want to understand why we never go to south. So when we go east, this is where we go east. We end up in a situation where basically like if len of nay roads is equal to 2, return panic. Good, because this is actually what we expect, and it does happen. So it does happen. Now, when that happens, we should do that first, really, because then if this is the case, there's really no need to do that check here. So it does happen when we have 2. But the random is always getting us this. Well, I guess it's an issue with random. Yes. Let's do that. Let's do that. Random range. The printf of error. That is the result. Next, the in -1. And then we're going to do like a time.sleep and 9. Hello, hello. That never happens. That is concerning. I thought we did get confirmed that if len of nay roads equal 2, panic good. Okay. No. So I understand what's going on now. So because when we are going east, we basically always keep going east. Like we never have any reason to go south. But in this particular case, because we don't want to do that. We don't want to move now. We basically always want to take one of the random one. All right. So I guess it is exclusive. We can get of the to-do. So the idea is that when we are in a regular road, the nay road is always going to be just one. So you're just always going to keep that one. And when we have more than one, it's going to pick one of the two. And the only case where it's going to go back is a case where like there's nothing in front. So that looks actually pretty good. Pretty happy about this. It took a bit longer than expected. We are like at the hour mark. So I guess we can just we can keep going. We said like this is from 16 to 6. Except oh yes, let's go back to where we were. I think it was on 16. No, I believe it was in 10. Yes. Looking pretty good. Let's add 2 of them. And now let's add a bit more roads, so that way we can do the crossings and some other things. So let's add one of those 4. Let's say we start at 3 plus I, and it's going to be 21. Nope. It's going to be at 15. All right. So now we have this. We probably want one that goes on the other side. For I range 3. 20 plus I. Oops. Did I? 23 plus I, excuse me. Oop. What if we do 24? Okay, 23. So we have this, we probably want the T in all directions. So let's do that. And maybe one more. So this one is going to be 23 is going to be, I believe 6 minus I. Not 26, excuse me. 5. 3. 4. All right. Let's get rid of this one. 2. Let's get this on the bottom. So it's going to be like in 6, I believe. No, it's going to be in 5. All right. And then we have this guy in 5. So now it means that we have a T on the right, but it also means we don't have like the we don't have the corners anymore. Well, we can add them, but those are just the T's. Those are actually the same. Not really sure why I did that. Ah. Yes, there's not a lot of point of doing this at all. So like we just need 2 of them. And because we actually like even those 2 are the same one as in the middle, we really don't need them at all. Much better. What we do need though is going to be on the side. So like let's do something like this of 2 or maybe 3 is going to start at 24 plus I, and it's going to be on 3. Let's see. Perfect, except it's going to start at 23. That one we need. And we need the same on the other end. Let's start at 3 minus I. Actually 4 minus I. Alright. We can change it a little bit to be symmetric. I mean not symmetric but flipped. Alright, so we have this. It goes a bit everywhere, that is pretty cool. And the one we are missing is going to be a full cross. So this guy here, we can change it to make it at 10 or at 9. And make another one. Actually, no. let's just keep it, that doesn't really matter. That's one here, we can extend it a bit further. Can do 6. And take that and cross. Voilà. It is going to be, let's say, at 26. And it's going to be starting at 1. Or maybe at 2. And it's 3. All right, I believe now we have, yes, we have the corner down, corner up, corner left, corner right, and cross. So we can go to the road. And we can add a few cases. Case basically like north, south, east, west. That is going to be a cross. And why I can't find the cross? Okay, I think it is here. Let's add it. Well. Box string characters. Where is the cross? Where is the cross? Again. It is here. Return of this. Let's see if that works. Then we will have this guy. We will have this guy. We will have this guy. Up. And we will have going up. Where is it going up? Where is the going up? It is here. Up. Alright, so we have the characters. So the going up, that is going to be if we do have a north, if we don't have a south, and we have both east and west. Oops. East and west. Case. Wait on this. Going down. Case it means that if we don't have a north, but we do have a south, we have east and we have west. Going, we can do this one first. If we have both north and south, and if we do have, we don't have an east, but we do have a west. If we have both north and south, and we do have an east, but we don't have a west. Or something like that. Pretty happy with this. Let's commit that. Let's see, what did we do? Yeah, we added the random, like we added a small helper with the directions. We updated that filter. We created a filter to filter out in top of the filter in that we had before. We actually implemented the random. Excuse me. Yeah, we just renamed the run to run type, and we actually pass the house now to the worker. Here we, it's the main, we added a bit more roads. We actually implemented the road rendering. Here, what did we do? This is all the logic for the worker itself. So that is like all the rendering logic. So we can say that implement roads north, south, finalize rendering logic, add helpers for moving. push that, bien sûr, of course. And are we calling it today or not? I would think so. Like that was a road system. Like we didn't really achieve all the goals, but having like a better road system was something I wanted to do. Next time we will do the resource system and implementing a different building. Or could we do that right now? Let's do that right now, you know it. It's fine, it's going to be a bit of a long video, but hey. Let's do that. So we are going back to our main. And from our main, the goal right now is going to create... Oh, right. Never mind then, I do have to run, I am sorry. We will implement the well and the resource next time. Have a good day. Thank you for watching.